This is a particle podcast. WA Science told different. Powered by SciTech.
Please Look Up is recorded at SciTech on Wajak Noongar land. Good evening, everybody. Welcome to Please Look Up, your monthly deep dive into all things space.
And commentary.
My name is Leon.
And I'm Beth. And in this episode, we'll be discussing the latest space news.
And everything you can see in the night sky in the month of September. So, Beth, tell me about the night sky for September.
Well, in the night sky this month, planets are pretty much king. We've got some awesome planets going on. Saturn is in opposition.
That's an excellent sentence.
I
Please
know.
tell me what on earth that means.
What on earth does Saturn in opposition mean? Well, Saturn is in opposition, which means that at the moment it's pretty much directly on the opposite side of the sky from the sun.
Right.
So if you are watching the sun set on an evening and you put your right hand towards the sun and you put your left hand out so that you look like a big T, Saturn should be rising on the other side of the sky.
Oh, I see. So you're pointing in opposite directions.
Yeah, if you point in opposite directions and you're pointing at the sun, you should be pointing roughly at Saturn on the other side. So as the sun is setting in the evening, Saturn will be rising in the east on the other side of the sky.
Perfect. That makes sense.
Yeah.
So I guess that means it'll be up all night.
Yeah, pretty much all night. So if you see a bright star, or something that looks like a bright star rising in the east, it will probably be one of the first things that you can see. Planets generally tend to be quite bright, and Saturn is quite a bright planet, but it's a planet, not a star at all.
Of course.
Yeah. Venus is also doing its lovely thing in the evenings, so you should be able to have quite a good view of Venus.
Yep. And that's out in the west. I've been looking at that.
Yeah, so that's on the west, so the same side of the sky that the sun is setting. There will be Venus. On the other side of the sky, there will be Saturn.
Gotcha. And having looked at both of these quite a lot in the past,
Yeah.
they both kind of look a little bit yellowish.
Yes, they are a little yellow. And Saturn, of course, if you do have a small telescope, absolutely go and have a look at Saturn, because you can see its little ears.
Yes, its ears.
Or rings.
I'm familiar with the history of the ears, but I would love you to tell us the story of the ears of Saturn.
Well, so if you look at Saturn with a small telescope, it doesn't necessarily look like it's got rings, but it doesn't look completely round and circular either. It's got two little lumps on either side of it.
Yeah,
so
the little bits that stick out on
Yeah,
either side.
so people used to call the rings of Saturn Saturn's ears instead.
Yes, and I remember, I think that goes all the way back to Galileo, who
Yeah.
was the first person to look at Saturn through a telescope.
I still just find it incredible that Galileo did that.
Yeah.
Like, I know that's something that's kind of weird, but like Galileo discovered some of Jupiter's moons. We're talking like so long ago that people had telescopes. I just think like it's really weird because we think of telescopes now as these hugely complicated pieces of equipment that use like radio waves and all sorts of bizarre things to look at the sky. But
Yeah.
you know, people for hundreds of years have just been looking up with a pair of fancy glasses, basically.
Yeah, a couple of lenses stacked on top of each other.
Yeah, and see that Saturn has little ears.
Yes, it does.
Or rings, if you insist.
I do insist. Actually, it's worth pointing out that Saturn is moving into its own equinox, which is when it will be kind of side on to the sun. So Saturn has a bit of a tilt, like Earth does.
Yeah.
And you know, as Earth goes around the sun, we get our seasons. That's what the tilt does for us.
Yeah.
And right now in September, on the 23rd of September, we're going to move into Earth's equinox, which is when the sun and the Earth's equator are like kind of perfectly aligned.
Okay.
And it turns out Saturn is doing the same. March next year. So
Okay.
it's a lot further away. But what that means from us,
Soon in space terms.
soon in space terms,
Yeah.
what that means for us is that in March next year, Saturn's rings are going to be side on to Earth, and so it's almost going to look like they're going to disappear. I've heard other people talking about when are Saturn's rings disappearing. Well, they're not going away, but viewed from Earth, when viewed from side on in March 2025, they're basically going to be invisible.
And that's just because so if it's like a plate, that plate is on its side to us, whereas at the moment Saturn is slightly tilted towards us, so you'd be able to see a little bit more, and you sort of get a more oval shape.
That is exactly.
Rather than a line.
Yeah, perfect analogy. We're seeing the plate from side on.
Yeah.
In
March.
In March, yes. That's right. At the moment, it's a little bit tilted to us, but sooner or later, it will be completely side on.
How long will that last?
I imagine maybe a few weeks.
Okay.
So Saturn takes about 28 years to orbit the Sun, and so its seasons last about 7 years. So 7 years of summer, autumn, winter, and spring.
I could do with the 7 years of summer bit, but
I could do with the 7 years of winter.
which one of us grew up in Australia? Which one of us did not?
Yeah, exactly. I think we might have to swap countries.
Maybe a little bit.
Perfect. Oh, you've got your passport here?
I do have my
Okay,
passport.
I'll just shave my head and we'll look perfectly the same.
We'll be identical. We'd definitely be able to just swap passports.
But yes, so because of Saturn's 7-year seasons and 28-year orbit, it means that things happen a lot slower on the planet. But yes, as
so
it gets
it's got
to
a several
equinox,
week equinox, not a day equinox.
yeah, instantaneous equinox.
Yeah.
Exactly.
Cool. So Saturn, really good. Venus, awesome. Other side of the sky, where the sunset is. Spring equinox, September the 23rd.
Yes, which we just kind of cover quickly.
Yeah, which means we're getting into spring.
Yeah, that's
Although
right.
I think technically, again, very Australian way of doing things. The start of the month being the start of the season. That's not how they do it in the UK. They're just like, it's mid-March. It's a season change.
Yeah, that is an interesting thing, that there's sort of a few definitions of seasons.
Yeah.
In fact, we're in Perth, obviously, and we're on the Noongar Budja, where there are 6 seasons.
Yeah.
So we're currently in the season of Jilbar, actually, which is the second... it's like the season of fertility.
Okay, so like when the rains are sort of bringing that life back to everything ready for spring, like what Westerners would call spring.
Yeah, that's right. And then next month we move into the next season, and then that's the season of life.
Yes.
But yes, that's obviously the Noongar season.
Well, you know what? I moved to Australia. I was like, your seasons are a bit weird, and then I found out about the Noongar seasons, and I was, they're better. They work better.
Yeah, they do work
Funnily
better.
enough,
Yes.
60,000 years of living here gives you a better impression of what the seasons
You're a
are.
bit tuned to the landscape.
Yeah.
But yeah, it's worth pointing out that that's very specific to where we are.
Yes, in Perth.
In Perth, yeah. There's obviously every different country of First Nations people has different numbers of seasons.
Yeah,
In
well,
fact-
because, Australia is so big that even within Western Australia, which I know is like half the country, but still, even within a single state, you've still got a huge difference in latitudes. So, some of Australia is subtropical, some of it is desert, some of it is relatively temperate.
Yeah, it's just the whole...
Tasmania.
Yeah, the whole lot. And in Darwin, there's the country is the Larrakia country, and there are 7 seasons there, which is obviously different to here in Perth with the 6 seasons of the Noongar people. But it's because of the different climate that's there.
Yeah.
But to go back, there's also the meteorological seasons, which summer begins in December, January, February, and then there's autumn, winter, and spring.
In Australia.
In Australia, yes. But then there's also the astronomical seasons, and they they are defined by the equinoxes and the solstices.
Yeah.
And so, yes, here we come into the September equinox, which on the 23rd of September, that's when the astronomy season of spring begins.
So what is the equinox? Like, what does equinox mean?
Yeah, so as Earth moves around the sun, because we are tilted, as in the entire planet is tilted by 23.5 degrees compared to its orbit.
Yes.
So, yes, you imagine a car going around a racetrack, but imagine it's like at the Olympics.
In fact, like
the
the
bicycles.
velodrome.
The velodrome, where everything's on its a little bit tilted. It's not completely sideways, a little bit on its side. But what that means is the sun in the middle shines at a different angle onto the Earth, depending on where we are in our orbit. And so the equinox is when we're exactly kind of sideways. So in summer, the south pole of where Australia is, that's the southern hemisphere, is kind of pointed towards the sun. But as we move around the sun, in winter, the northern hemisphere is pointed towards the sun. And then there's obviously somewhere in between.
Yes.
And right now we are exactly in between. On the 23rd of September, we'll be exactly in between. Neither the northern or southern hemisphere will be pointing towards the sun. The sun will be sort of kind of hitting the Earth exactly side on, all of that sunlight. And the exact day that the sun is kind of over the equator, that's what we call the equinox.
I want to jump back a little bit to our planets, because I said that planets ruled the entire sky, not just the evening. They are also in charge in the morning this month with the wonderful Mars and Jupiter.
Yes, please do. Tell me more.
Yeah, so Jupiter, king of the planets by name and the biggest one as well. So it'd probably win in a pushing contest. Well, does gravitationally by the number of moons that he's got going on. Or Saturn is overtaken.
I think Saturn's the record at the moment, but Jupiter still wears
Still
the
up
pants.
there, yeah. And then Mars doing its red thing.
Doing its red thing. Yeah, I was out looking at these the other day because I've become a monster, and sometimes I get up before sunrise.
Have you betrayed me and gone to the morning people?
I have. I don't like it either, but just occasionally I've gotten up and going for a morning walk.
Oh my
And
goodness.
yes, I saw them the other day. Amanda and I mentioned in the August podcast they had a close approach on August 15th, where Jupiter and Mars were separated by less than a finger width, like held out. You hold your pinky out.
Oh, okay, so in the night sky, very close together.
Yes, that's right. Well, in the morning sky, very close.
In the morning sky.
But yes, they have drifted apart. Jupiter's kind of overtaking Mars, so Jupiter is up quite high. So if
So
you're
what
out,
part of the sky were we looking at here?
so yeah, we're out. We're talking about 5:30, maybe 6 o'clock in the morning, and we're looking to the east. So before the sun rises. So the sun rises in the east as well. So just look to where the horizon is starting to get a bit bright, and that's where that's east.
Yeah.
And you'll see Jupiter. Jupiter's a bit higher up and is very, very, very bright. It's bright. It's kind of whitish. It's so bright. And then you've got Mars about a couple of finger widths below to the bottom right of Jupiter, and it's kind of red. It's doing its red thing. Yeah, exactly. But it's definitely nowhere near as bright. So you kind of need to look for it. Jupiter's obvious. Mars is not so obvious, but it is there.
So because of Saturn being in opposition at the moment, so if I stayed up all night and watched Saturn go across the entire sky, as Saturn is setting, Jupiter and Mars are rising in the other side of the sky just before the sun.
That is exactly right.
There you
So,
go.
yeah, in fact, if you are up early enough, you might even choose to do that as your morning observation.
Yeah.
See Saturn setting in the west, and then turn around and see Jupiter and Mars rising in the east.
So speaking of other things rising and being very impressive in the night sky, September the 18th, we've got a full moon.
Yes, we do.
And not just any full moon.
No.
It's a super moon.
It's a supermoon.
See, Leon, I think the moon is always super.
I do too, but the media...
What does it mean?
Yeah.
What does it mean, Leon? We've discussed blue moons before,
Yes.
but what's a super moon?
Yeah, what's a supermoon? Good question. So the supermoon is... It looks a bit bigger. That's the simple answer.
Genuinely just, it looks a bit bigger.
Looks a bit bigger. and actually, more importantly, it looks a bit brighter. In fact, that's the thing you'll most likely notice. It looks a bit brighter. So what is a supermoon? So the moon's orbit around the Earth, it's not perfectly circular. So we all know the moon goes around the Earth.
Yeah.
But rather than being a circle orbit where its distance from the Earth is always exactly the same, it's elliptical, it's oval
Slightly
shaped.
offset.
Yeah, slightly offset. And so what that means is sometimes the moon is further away from Earth and sometimes it's closer to Earth.
And when it's closer, it looks bigger and brighter?
Yes, that's correct. When it's closer and a full moon, that's the important thing. So the important thing to notice is that once a month the moon is close to Earth, but it might not be a full moon. It might be a quarter moon, it
Right.
might be a new moon, it might be any particular phase. So it happens every month, once a month, doesn't matter.
Right.
Once a month, I should say.
Once a month.
As we've mentioned, month is the derivation of month. Well, actually, the other way around. Month is the derivation of month. But yes, when the full moon coincides when the moon is closest, that is what we call a supermoon.
Cool.
And as a result, it is, because it is slightly closer to Earth, it does look bigger in the sky, and this is true for every time it's closer. But because it's a full moon and it looks bigger, it's also going to reflect a lot more light, about
Right.
30% more light. So
So-
it does look brighter.
Am I going to be able to go outside and read a book?
You can, not like perfectly, but if you have
Still
decent
squinting.
eyesight, you don't have glasses or cataracts or anything
Yeah.
like that, you can read a book by
The
the
light
light
of a supermoon.
of a supermoon.
Wow.
And yeah, I've definitely gone walking and out without any lights or torches or anything like that, and I assure you, you can see things in the dark with the light of a full moon.
Brilliant. Oh, that's so amazing. So there's a couple more things if we're watching the moon this month. And on the 10th is... Well, okay, I've written this down. I'm going to try and read this word out loud because it's one of our big space words. So is the moon Antares occultation?
Oh, the occultation.
Occultation.
Yes, that's right.
Why is it not just occlusion?
I don't know. It's an old astronomy word, and it means a thing.
It means like blocked off, doesn't it, basically?
Yes, that's right.
It's sort of... So... for context, we know what the moon is. The moon is the moon.
Yep.
It's doing its big thing on September the 18th. But Antares is a star.
It is.
So
We've spoken
Antares,
about it before.
yes, we have. It's a big red star in the middle of Scorpius. So the occultation is basically the moon eclipsing Antares.
Yeah, that's right.
Yeah, so the moon will go in front of the red star, which means it goes invisible. Well, no, we just can't see it.
Yeah.
It doesn't turn an entire star invisible. But
Yeah, I think occultation is the sort of
Occultation.
stand-in word for eclipse.
Yeah.
Because, like when the moon moves in front of the sun, we call it an eclipse, and it's
Yeah.
amazing. But then, it passes in front of a star, and it's called an occultation. But it's basically an eclipse. It's just that, we don't get the corona or anything like that. The moon's
No.
obviously...
It's not as important.
No, as it appears from Earth, the moon looks much bigger than any of the other stars. But yes, that's right. And this is something that's almost unique to where we are in Western Australia.
Oh.
Because the moon is so small, as
Angles.
you've said, the angle does matter. So if you're far over east or far over west, it's actually not going to occult Antares. It's going to pass close to it, depending on where you are on Earth. But in Western Australia, it's kind of unique to us. And so, we get to see the moon pass in front of Antares in the Scorpion.
So surely the moon is occultating stars? Occulting stars fairly often.
Yeah, all the time.
Right, but it's just that Antares is such an obvious one, and if you're used to looking at the Scorpion and you suddenly can't see it is quite obviously red
Yes.
In the middle of it, so it just happens that we'll notice this one.
Yes, that's exactly right. So, you're 100% correct. The moon passes in front of stars all the time, but... Antares is cool. It's
Yeah.
awesome. It's literally a cold star.
It's
It's only
not-
about 3,000 degrees. Only.
It's
Compared to the
cold
sun.
by
6,000.
by star standards.
By star standards, it's cold and it's old and it's big, but we still love you, Antares.
We still do love you, Antares.
So, keep your eye out. That's on the 10th of September.
And it's in the evening as well, isn't it?
Yes, it is. It's about 11 o'clock in the evening, and it's very transient. Like if you're out on the 12th or the 9th or the 11th, or even if you're out at 9 p.m,
Yeah.
you'll miss it. It's from about 11 p.m. till about 12 p.m.
Okay, so you have got an hour. It's not quite blink and you'll miss it,
No.
but it is a very
But it is
specific...
snooze and you'll listen.
Yes. Just take a nap at the wrong time and you are going to miss the occultation
Occultation, there we go.
of Antares by the moon.
You've learnt a new
I
word.
have learnt a new word. It's very exciting. Speaking of new words,
Yes.
we're going to change up our order a little bit
I
and
think so.
dive straight in to Deep Sky Dictionary.
Deep Sky Dictionary.
I am not sure I know how to answer
Deep Sky
that.
Dictionary.
So our word this week is celestial.
Celestial. Ooh,
Celestial.
now that is a good word.
It's a good word. It's a beautiful word.
Tell me, Beth, what does celestial mean?
so-
I kind of know what it means, but it's
Yeah, so
I've never
it
really had
can
it defined.
it can mean three different things, according to, of course, our source of Google, which I think is supported by Oxford dictionaries.
Oh, sure.
At least when I Google things. I wonder if you can change that. Anyway, that's for another day. So the third meaning is supremely good.
Ooh.
Yeah, often when used when referring to a piece of music, which I think is
Ooh,
more a
okay.
sort of evocative term.
I'm thinking of Ego in Guardians of the Galaxy 2. And
Yes.
He's a celestial.
He is a celestial, yeah,
Yeah.
absolutely.
I love that movie. It was so good.
It's a good movie.
Yeah.
It's a very good movie. Celestial can also mean, the second meaning it gives,
Mm-hmm.
Google gives, is belonging to heaven.
That makes sense.
Yep. And the first meaning it gives is positioned in or relating to the sky. Now,
That also makes sense.
yeah, it makes perfect sense. So, celestial is, weirdly, you could use celestial to refer to an aeroplane
You could.
because
yeah.
they're just in the sky.
That's true.
So I think that actually this word might be evolving right now
Yeah.
to mean not just relating to the sky, but beyond the sky. It's more relating to space than specifically the sky.
I've always taken it to be related to space. And
Well, funnily enough, I looked up the etymology of celestial.
I love etymology.
Where's this word come from? It's from the Latin via Middle English and Old French,
Perfect.
and it's from Latin caelum, which means heaven. So actually the second meaning of celestial, of belonging to heaven, is the more
Is the original.
It's the original version. So already our usage of this word has evolved from heaven as a concept to heaven as the place, as in the heavens above that we can see, rather than the theological heaven.
Yeah. That's really interesting.
Yeah. So celestial is quite often tacked on to a lot of other words in space terms. So a celestial body, really, really useful word, especially for us in the planetarium, because if we're wanting to refer to stars or planets or moons, stars, planets and moons are all celestial bodies. They're all things in the sky. But there's some other terms that just get celestial tacked on to mean in space context.
Yeah. Well, I'm just thinking now because I remember spending a lot of time studying celestial mechanics, which is the movement of objects in space.
Oh,
yeah, but obviously in particular spacecraft. And when you have a central point of interest that pulls everything in, also known as the sun, it interferes with the straight line motion that Newton's laws tell you you'll get. Objects in motion move in a straight line. Well, they do, but
unless you've got some massive thing giving off, sucking in with huge amounts of gravity.
Exactly, and so you no longer talk about like straight line trajectories and momentum. You start talking about orbits and inclination and things like that. And yes, I know in relativity things become straight lines in curved space, but it doesn't matter. But yeah, celestial mechanics is a huge part of any study of getting anywhere because we might, spoilers, a little bit later we're going to talk about something called the escapade spacecraft to Mars. And you can't go to Mars whenever you want. You need the celestial mechanics to work out when Mars is in the right spot.
Yeah,
that's you can't just launch whenever you want. I mean, you can, but it's very expensive and costs a lot of fuel. You need to, if you want to do it the best way,
you've got to get your timing right.
And
you've got
celestial
to know.
mechanics gives you the answer.
Yeah. So that's our Deep Sky Dictionary this month. It's sort of short and sweet one, but celestial, a word that I appreciate for being able to be used in something very scientific and complex like celestial mechanics, and also to be used for something ephemeral like that musical piece was celestial.
Yes, what a great word. Thank you, Beth. Good choice.
Thank you very much. So continuing on from that slightly artistic Deep Sky Dictionary, I'm here with the transitions today.
Oh, I love it.
Because we're going to move on to Space Picture of the Month. Oh, Leon. Oh, this is a series of 3 pictures and they're not looking good.
I'd like to point out it is still one picture compared to a couple of months ago when I gave you 3 pictures.
Yeah, no, this is one picture with 3 frames in it, as opposed to the 3 entirely separate pictures. Are you sure you've got this in the right segment, Leon? This looks more like a space fail.
It does. I've decided we've got something different for space fail.
Okay, all right. Like sneaking segments into other segments.
I know.
Okay, so our 3 images. On the leftmost side is a rocket ship having a good little time. It's launching, it's blasting off, it's got its lovely bright trail behind it. And then the second picture is, I'm presuming, the same rocket ship falling sideways out of the sky, trailing smoke. And then the third picture on the right is, it looks like it's taken out over some buildings to a hill. And behind the hill is a big explosion. What happened, Leon?
Yes, so this is a Chinese rocket, and this picture is from a couple of months ago, but I thought it's still worth mentioning. So this is a failed rocket launch from a Chinese experimental rocket that's trying to compete with the SpaceX Falcon 9.
Right.
So you know the SpaceX Falcon 9 that launches and then it lands on the barge in the middle of the ocean?
Yep.
Yep. So this is a prototype version of a competitor to that rocket. And they were doing a test fire of the engine.
Just before we get into it, no one on this rocket?
No one was on this
rocket.
Good. No, good point. Yes, good question.
Just making sure.
Yes, in fact, this was entirely a test where they were just testing the engines to check that they would all light up. And when they test the engines, the rocket is bolted to the ground. So it wasn't. This launch wasn't. It wasn't a launch. It was bolted to the ground.
Oh no! So the first image where I was like, "Oh, there's a triumphant rocket." It's an escaped. It's an escaped rocket. It's running away.
Yes, that's right.
Oh no!
its engines were a bit stronger than the bolts, and the rocket took off unintentionally, an accidental launch, which is one of the fewest things that ever happens in launch history.
An accidental launch. I accidentally launched a rocket ship is not something I think many people in this world could say.
No, that's right.
But equally, I'm surprised in a way it doesn't happen more often, because you're like, oh, it was bolted to the ground. And you're like, yeah, of course it was bolted to the ground. But also, it's a rocket ship.
Yeah, it's interesting because a lot of rocket engines are tested horizontally, so they put them against the wall and against like a concrete or a huge hill.
Yeah,
and so when the rocket fires, it fires sideways, and if it
so they just blast it into the ground.
Into
basically.
the ground, yeah, that's right. Whereas this one, for whatever reason, was pointing vertically, ripped free of its constraints.
Oh goodness!
And it appears to have been fully loaded. China is notoriously secret about their entire country.
Space.
Yeah, and space.
Yeah.
And so, but as you mentioned in the third frame, there is an explosion, and you can do some maths on the size of the explosion, and it seems to be that this rocket was almost fully fueled.
Right.
So it might have been like they were probably trying to do a full duration test burn. So, a 10-minute burn, which is about how long it takes to send a rocket to space.
Yeah, just making sure that the rocket is actually going to burn up all of its fuel. They haven't put too much in or too little in.
And the engine can fire for that whole time. Because, if it fires for 3 minutes and then turns off, that's not enough to get you to space.
No, important stuff to have tested on the ground.
Yes, unfortunately, it got off the ground, flew for about 30 seconds, an engine exploded, it spun out of control, and that's where you saw the rocket falling back to the ground in the second frame with smoke trailing all over it.
Oh, no.
And then the thing you mentioned is that it looks like in the foreground, in that explosion, there are buildings, and that's right. There is obviously a safety zone around this test flight.
Yeah.
But, it wasn't meant to be a test flight.
If you're not expecting it to fly, then you're probably not going to have quite as wide an occlusion zone.
That's right. It was never meant to fly, and so the exclusion zone is only about 10 kilometres, and it very nearly made it to the edge of that 10 kilometres before exploding. So yes, it was a hell of a test and a very, very lucky failure. Yeah,
a lucky failure, absolutely. I'm glad that no one was hurt.
Yeah. Yes, no one was hurt. As far as
hopefully,
no one was on board.
Hopefully, this means that for their next vertical flight test, they do it further away.
I would like to think so.
That would be nice. Yeah. All right. I'm interested to see what's coming up in Spaceflight Fail if that rocket ship didn't make it in there.
Yes. But I'm keen for your space picture of the month.
Okay. I actually have 2 pictures for you this month.
What is this?
Revenge is what it is.
Okay.
This, Leon, is a great... Well, describe what you're seeing.
Okay, I'm seeing a big tractor. That's it occupies the vast majority of the field of view. There is a big green tractor with big wheels, and there is a paddock in the background of crops of some kind. I don't think that really matters. And there is a setting sun in the background, and the tractor is on grass in the foreground. It is a huge, big old tractor. It
is a great tractor.
It looks a little bit AI generated to me, but...
Well, it's a great tractor. Because the second thing that I have to show you is the great attractor.
I know what this is. This is Laniakea.
Tell us what you're seeing, Leon.
Okay. So this looks like if you've ever seen like X-rays, or not X-rays, but pictures of veins, and how the vein sort of has the main sort of...
Oh, those like disembodied veins where it's like just a nervous system model.
Yeah, where you've got sort of a main thing, and I'm showing my ignorance of knowledge in biology, so I don't want to choose the wrong words, but you've got a sort of main artery, and then it branches out, and then it branches out and branches out and branches out and branches out, and it gets thinner and thinner and thinner every time. That's kind of what we're looking at. And it's this big branching thing, but I know that it's not a human nervous system. Please tell me what it is, Beth.
So this is the Great Attractor, or the image is of a region known as the Great Attractor, and the Great Attractor, not a great tractor, even though I wish it was.
I love it.
Is the central gravitational point of the Laniakea?
I looked this up many months ago. Laniakea
supercluster.
Yes.
So much stuff in space. I read it, I'm confident, and then I'm wrong.
It's a Hawaiian name. I can't remember what. I think it's a goddess, but I might be wrong there.
So the Laniakea supercluster is 100,000 galaxies.
100,000.
100,000 galaxies, including the Milky Way.
Right.
So this point, the Great Attractor is the central gravitational point that those 100,000 galaxies are moving around, basically.
Right.
It's about 205 million light years away from us, the Great Attractor. And so what we're seeing in this image is the... it is those...
The flow lines? Is that the word we're looking for?
What, the flow lines, yeah, exactly. So
like if every galaxy moved under its, if we could fast forward time, they would move on those lines.
what's it called? Like a it's like a long exposure photo.
Yeah.
So like when you do that with night sky pictures and you just see all of the stars as little lines across the sky.
Kind of
It's like that, but on a galactic scale.
Yeah.
So this is not a real image.
Yeah.
It's a generated from a data set.
Yeah.
But yeah, it's...
So if you could take a 200 million year time lapse of the universe and watch those galaxies move,
yes, they would be
follow
moving. Yeah, following those lines, those capillaries.
Yeah,
that.
And it's worth pointing out, rather than going out from the main capillary artery, they kind of they move in towards it because gravity pulls things together.
Yes, exactly. So whereas we would probably think of maybe something like a river as well, being like you've got the main river section and then little bits coming off it, but it's actually not. It's all the little bits flowing into the main river.
Right, and we all move towards the Great Attractor.
And we're all moving towards the Great Attractor. Or a Great Tractor.
I love that you picked a picture of a tractor.
I would love if we got there one day and there's just a tractor sat in the middle of space.
Sure.
That would make me
definitely
happy. So you and I cannot see the Great Attractor because it is in our night sky obscured at visible wavelengths.
Yes.
So you can see it in the night sky using non-visible light.
Right.
It's between Triangulum Australe and Norma.
Ah, I know those two constellations.
Yeah.
Most people don't. What are they?
So Triangulum Australe is the Australian triangle.
Mm-hmm.
Yeah.
That sounds like it.
It's just a triangle. It's also known as the Southern Triangle because the Summer Triangle is a
northern constellation.
northern asterism. So the Summer Triangle is made up of three different constellations in the three different stars, part of three different constellations in the northern hemisphere.
But yeah, it's not a constellation by itself.
No, so Triangulum Australe is just a triangle, and Norma I think is a set square.
I believe it is, yes. Yeah, you're right.
Yeah.
Yeah. These southern constellations, they're great, aren't they? A
Yeah.
triangle, a set square.
And some birds.
And some
nice birds.
Yes, there are birds.
Yeah, but the Great Attractor, the part of our night sky that it's in is between the triangle and the set square, but we can't see it with the naked eye.
Yes, I recall now it's seen by gamma ray bursts, is that right?
Yes, I think so,
Yeah.
as far as I recall.
So every now and then we get a huge burst of gamma rays from space.
Yeah.
And they've been linked to exploding stars, and a big burst of gamma rays just shoots out when the star explodes in a supernova classic.
Yeah.
And there seems to be an overdensity of gamma ray bursts coming from that region of the universe, that direction, and that distance. And
yes.
So, astronomers have been able to conclude there's a huge overabundance of galaxies in that area.
Yeah, because of this gravitational pull in that area.
Yeah, and it's kind of self-perpetuating. There's lots there, so it pulls more in. And there's lots more, so it pulls more in.
So we can't see it because the Milky Way is in the way.
Yes.
As with a fair amount of space stuff.
Fair chunk of the universe, yeah.
Yeah, so when we're looking at different galaxies, if you would think about our perception of our map of the universe, at the moment, it's, when we go out to a galactic scale and an extra galactic scale, it's sort of butterfly shaped.
Yes.
Because it's easier for us, again, if the Milky Way is a plate, it's easier for us to look up and down, because if we look sideways, the plate is in the way.
Yeah, that's right. We are the peas on a plate, or we're the cookies in a biscuit.
Yes.
Is the way I like to think about it.
Chocolate chips in a biscuit.
Yeah.
We can see up. We can maybe a big chocolate chip and a biscuit. We can see up, we can see down, but sideways there's biscuit in the way.
How many other analogies can we go? We're the tempura crisp in an okonomiyaki.
Oh, that's a good one.
Sure, why not?
Maybe. What else? We're the sugar on a donut.
Yeah, I guess so. Yeah.
You can see up and down, although there's a hole in the middle there, and then might get into some weird galactic theories. I'm just thinking of food. All of this has been food, Leon.
Yeah.
Are we hungry?
I think so.
Yeah, probably. But yeah, that's the great attractor. Or if you're a little bit cheeky, a great tractor.
A great tractor. I love it. It didn't occur to me that until you said the great attractor, why you had sent me a picture of a tractor. I'm not very quick on the uptake.
I'm so
like
glad that I got you with that.
Yeah, you got me good.
So, interestingly, again, transitions today. Triangulum Australe sort of links us in a bit of a weird way to our constellation of the month.
Constellation of the month. Orion.
Yes, yeah, that's right. I actually spelt it wrong when I was selecting this, and I wrote down Triangulum Australis. But no, the constellation of the month is Corona Australis.
So, first off, I want to talk about the Australis Australe thing.
Yes.
So, when we're looking at space stuff and naming space stuff, it's a bit like the whole eclipse occultation thing. We needed a word to describe Australian. So we went with Australe and Australis and Austrinus.
All of them.
Why?
I don't know.
It's infuriating.
Australia, it means south.
Yes.
That's why we're the Great Southern Land.
Yes.
And you can tell me what language that comes from. I don't know. Probably
Greek.
But yes, that's right. Because last month we had Corona Borealis, the northern crown, as the constellation of the month, which Amanda and I spoke about. And this month I've decided it's going to be Corona Australis.
The southern crown.
Now,
Did you talk about the other elephant in the room of Corona?
No.
So I think we discussed it briefly before when we were talking about eclipses.
Yeah.
So Corona, obviously, a lot of people now know it in its relationship to a virus.
Yes.
So they know it as a virus. So it's the coronavirus.
Yes.
Why are we talking about corona in space? Don't worry, it's not a space virus.
No.
Corona means crown.
It
so
does.
this is where my background comes in a little bit. So my background's actually in biochemistry and microbiology. I just am also a nerd, so I like space as well.
Love it.
So the reason that coronavirus is called coronavirus is because of its shape.
Yes.
So you've got a central virus shape, and then you've got all these little bits sticking up from it, which sort of form a little bit of a halo or a crown around it.
Right.
So
So
it's
is
in the
coronavirus
same-
round?
What's that, sorry?
So coronavirus is round and
Yeah,
bits
the virus
stick out?
particle itself is round, and all over its surface, it's basically got these little sticks that stick up, and those little sticks are sort of flat on the end, or like we're talking a viral scale, so this is very, very small, so they're not actually flat because they link to things in the...
Yeah,
but
yeah.
anyway, but it makes it look... It's like a little forest of trees all over the surface of it, but like palm trees. So you've got that like stuff going on at the top of stems, and it makes it look like there's a little crown,
like a crown.
surrounding it. So if you're looking at it from the side, it looks like it's got a little circle around it, which is the same as in an eclipse. It's corona because it looks, you've got the circle and then you've got
Yes,
a little
the solar eclipse.
circle
the
around
sun's
it.
corona sticking around it. Yep.
Exactly. And so Corona Australis, Corona Crown. Yep.
Narrows it down.
Yeah, absolutely.
Makes perfect sense. And for Corona Australis, it's actually like Corona Borealis. It's more of a half crown.
Yeah, I always see it as more of a tiara.
Yeah, the tiara.
Yeah.
And it's a bit faint. So the way to spot it is to go outside and look for Scorpion, the Scorpius, as we saw before.
Yep.
And
So
Sagittarius.
if you're looking up for that occultation,
yes, yeah, you might
be
even
looking in the right direction.
Yeah, you might want to catch it on the same night. And it won't be far. So it's halfway between Scorpius and Sagittarius. So those are two very distinct constellations. Scorpion looks like a hook.
The teapot of
The
Sagittarius.
teapot of Sagittarius,
The
yeah.
rest of Sagittarius
Looks
is
like
a mess.
Yeah, it's scrambled spaghetti. But yes, and halfway in between there is the Corona Australis. And again, you might want to use our favourite app,
It's Stellarium.
Stellarium, monthly plug for Stellarium, just to help you find your way. And it's there. It's quite faint, but it is a half crown, and it's the constellation of month this month.
I would find the other thing that I say to tend to look out for in that is that because the tail of the scorpion is quite nearby, if you're not entirely sure what you're looking at, sometimes you can just see the tail of the scorpion as a C shape, like as a crown in the sky.
Yeah.
But that's quite bright and obvious. So if you look nearby and you can see another fainter, it looks almost like, I'd say almost like the shadow of the scorpion's tail.
It does, yeah.
So yeah, try
That's a
not,
good way to
don't
spot
get them
it.
too mixed up.
No.
But if you found the scorpion's tail, its little shadow of Corona Australis is nearby.
Yes. And so the reason I made it the constellation of the month this month is in August we spoke about Corona Borealis, which has many, many stories associated with it that we mentioned. But Corona Australis is, again, another one of those constellations where in the southern hemisphere, by the time it was mapped, the people making the maps were more interested in making the maps than they were about the stories.
Yes.
So there are no doubt many, many stories across Australia, First Nations people, and across the entire southern hemisphere about Corona Borealis.
Corona Australis.
About Corona Australis, but at the moment it's there because there's a northern crown, so we need a southern crown, and that's why it's there.
It's sort of the younger sibling in astronomy terms, like when it was named by Western culture.
Pretty much.
Yeah.
Now, if you do have a small telescope, within Corona Australis, there is something called the Corona Australis molecular cloud, which is very cool. So, naughty.
Sounds exciting.
But it's an example of what's called a dark nebula.
So it's not a cloud.
I'm going to call it a cloud.
Okay.
It's not a cloud in the sky.
Right.
It's a cloud of dust in space, which is very cool. And because
So like the Coalsack Nebula.
exactly. So if you ever heard of the emu in the sky,
Yeah.
and the Coalsack Nebula is part of the emu. The emu is probably the oldest constellation in the whole night sky, made out of the dark parts of the Milky Way.
Yeah. So the emu's head is the Coalsack Nebula.
That's right.
So this is another dark nebula like that one.
That's right. And it's kind of sitting in front of the emu's belly. So it's kind of at the middle of the Milky Way, but in front of it, a bit lower.
Yeah.
So it's not across the Milky Way where the emu is, it's a bit lower. And
Which would be why it's not a naked eye.
no,
It's not very obvious with the naked eye, and you kind of need a telescope to spot it.
that's right. Yeah, or you need to be away from the city lights. So yeah, get away from the city lights or get a telescope. And yeah, the Corona Australis molecular cloud, it's a dark nebula that blocks the starlight from behind, so it's kind of noted as an absence of stars.
Yeah.
But it is known to be forming new stars. Not in any time soon, but over the next sort of million years, new stars will form inside the Corona Australis molecular cloud. And so gravity pulls the dust together and it heats up and it ignites and eventually becomes new stars.
It's so exciting to me that something that is as permanent as the sky is changing.
That's right.
Like,
Just
stars are
non-human
dying all the
timescales.
time, new stars are being made, stars are moving, they're changing places, but so slowly that for us, the sky is, it's changeable, absolutely, but reliable.
Yes,
to
that's
us.
right. And that's what I like to say in the planetarium. The sky changes, but not that quickly.
Yeah.
Apart from the moon.
Yeah,
moon's
and the whole, every day,
Yeah.
it moves, but then it'll be back. They'll be back tomorrow.
No, it doesn't matter.
No, it's
Doesn't count.
It's like they'll be there tomorrow, but will they be? Yeah, it's probably. And even if they're not, we're not going to know about it for a long time.
When I was in year 10 or something, I did a maths test and it was like, what's the probability that the sun will rise tomorrow? And the answer was 100%, but I thought there's a non-zero probability.
There is a non-zero
that
probability
the Earth will get destroyed by a big asteroid tomorrow,
Yeah.
and the sun won't rise. And I got marked wrong for that.
Oh.
And I still to this day am bitter about it.
People need to give us more points for pedantry.
That's right. Yeah, ultimate pedantry is totally worth it. Internet, no, it's not.
No, maybe not always. I feel like a little bit of pedantry can be quite fun sometimes, though.
I think a little bit,
A little bit. A sprinkle.
Yes,
The essence of pedantry. Just don't be boring about it.
that's right.
But yeah, non-zero chance that the sun won't rise tomorrow. So enjoy the night sky tonight, I guess.
Yeah, exactly. And enjoy looking at Mars tomorrow.
Yeah, absolutely. In the morning, where it should rise, near the sun.
Yes, that's the plan.
Full circle. We're right back round.
Which brings us nicely into our next segment.
Does it?
I think so.
I've run out. I've done such a good job of
we're
links
good.
this whole time.
It's time for Space Flight Focus.
Space flight focus. I always want to sing I want to sing jingles, and I don't have
I
a
think you
song
should.
for any of the jingles.
Well, I think they should be done. Like, the jingles we're using are just kind of put together as needed. So
Yeah.
if you want to record them.
Oh, I don't know. I don't know if me going spaceflight Vegas in the background is going to be any
It's
good.
perfect. I love it. It's perfect.
So, what is our spaceflight that we are focusing on this month?
So this month we are going to be escapading to Mars on the New Glenn,
Oh,
which is a hell of a sentence.
That is a hell. I love astronauts and space people because it is one of the best places that I think we can remind ourselves that scientists are human beings with senses of humour, and those, like, not just senses of humour, but also other aspects of humanity, like the rovers that we've sent to Mars, like Curiosity, Perseverance, and then this one, it's just...
Escapade.
Escapade.
Yes.
We're going on an escapade,
We're going
a
on an
jaunt.
escapade.
I love it. I love it so
A
much.
quick pop out to Mars.
Yeah.
Yes. No, escapade is one of the less tortured acronyms. There are some really, really tortured acronyms that come from space.
Just stop making them acronyms. Just lean in to the fact that they are beautiful words.
I think so. So ESCAPADE stands for Escape and Plasma Acceleration and Dynamics Explorers, which is a...
What does that mean?
It's a pretty tortured one. What it is we want to study Mars's atmosphere. So what it is it's two spacecraft, about the size of a small table, and they are going to Mars in September, if
Those
all
are
goes well.
quite small spacecraft.
Yeah, that's right. They're only about 500 kilos each, which
Okay.
only, quote
Only.
unquote. About the
In
size-
space terms,
Yeah.
not that
yeah,
big.
compared to some
Wait
other
a sec. A
spacecraft.
table that's 500 kilos, though.
Well, yeah, well, it's made out of steel and
Okay.
well, not steel, but aluminium and electronics and things
Yeah.
like that. So yeah, about
We've
500
put a lot of
kilos.
stuff in this table-shaped space.
That's right, yeah, and it's a. There are actually two spacecraft. They're called Blue and Gold, and they are identical copies of each other. And they're going to Mars to study the escape and plasma acceleration and dynamic exploring.
What? Yeah, that's
What that
the bit. I
means.
still don't know what that means, Leon.
They're studying how Mars loses its atmosphere.
Oh.
And that's a very important question. See,
Well-
here on Earth,
First, to start off,
yeah,
I mean, Mars having an atmosphere is probably something that we don't consider very often.
No.
Because like the images of Mars, like I've always thought that when we look at the moon and we look at Mars, to me they look very similar, just with a different color grading on them.
yes, in a sense, yes.
Yeah, and the moon doesn't have an atmosphere. Mars does.
Mars does have an atmosphere,
But
however,
it's-
it is very thin.
Right.
And yeah, the moon, for all intents and purposes, doesn't. I think I read somewhere the moon's atmosphere weighs 160 tons, which sounds like a lot, but when you spread that out over something the size of Australia, it's not much.
Not much.
But yes, Mars does have an atmosphere. It's about 1% the thickness of Earth's atmosphere, so it still is very thin.
So
And-
it's only about what that would be a kilometre thick.
when I say thickness, I mean like wind resistance. So when you stick your
okay.
hand out the window
Yeah.
and that the wind blows your hand back out the car. On Mars, it's almost not there.
Okay, so we're not talking like
Height,
surface up
No.
thickness. We're talking about like
viscosity.
of atmosphere.
Yeah, that's right.
Okay.
So it's a very thin atmosphere, almost entirely carbon dioxide. So it's not breathable. You can't live there without a spacesuit.
Cool.
But the thing that seems very, very puzzling is that it seems like Mars used to have a much more hospitable, friendly, thicker atmosphere, almost possibly similar, in quotes, to what we have on Earth today.
Right.
So, and the reason for that is that we can see pretty extensive evidence that there used to be oceans on Mars.
Yes, there's some very, like, if you look at the aerial photos, you can see river deltas.
River deltas, yes. In fact, the Perseverance rover is driving through a river delta. There are sedimentary rocks on Mars that only form in stable bodies of water over millions of years. There's clay minerals. And clay, again, clay minerals are a very specific type of mineral. They only form in liquid water. And
Right, so there's very, very strong evidence that there was water on Mars
That's
once.
right. And the problem is, if you take a bottle of water to Mars and pour it on the surface right now, it will simultaneously evaporate and freeze at the same time.
Whoa.
The air pressure is just not high enough because the behaviour of water actually depends on air pressure. You might have heard
Yes.
about like going up Mount Everest and water boils at 80 degrees Celsius.
Yes.
Yeah, because the temperature at which water boils changes with air pressure. And not only that, as it boils, it cools down and it can also freeze. And so on Mars, water is not stable on Mars at the moment. However, we know the fact that there was once oceans on Mars suggests that the atmosphere was once much thicker, much heavier, and much more stable.
Right.
So the question is, where did it go?
Oh, so that's what these two rovers
are going to try and explore. And so what they're going to do is they are going to study the plasma environment around Mars.
What?
Yeah. So what we think happens is that the sun constantly streams out a constant stream of particles called the solar wind, and on
which
Earth,
is what causes the
auroras. Yes, because on Earth, I think it's auroras is plural. On Earth, we have a strong magnetic field. That's why compasses work.
Yeah.
And that magnetic field, in addition to pointing compasses, it also protects the Earth from these particles from the sun. It deflects them, and they lose a lot of their energy. So by the time they hit the Earth, they just kind of glow. They ionize the atmosphere, and the atmosphere glows, and it's beautiful. It's amazing. But on Mars doesn't have a very strong magnetic field, and it's inconsistent. It points in different directions. Compasses don't really point you north on Mars. They point in all different directions. And because of that, the atmosphere of Mars is unprotected. And so this solar wind, think of it as sandblasting.
Right.
Mars's atmosphere is constantly sandblasted by the sun.
These charged particles.
Just
destroying the atmosphere.
Yeah, they just strip it away, atom by atom. But when you've got billions of years...
Yep, and billions of particles.
It just adds up. And so over billions of years, the atmosphere of Mars has been stripped away. That's what we think, because it doesn't have a magnetic field to protect it, or a strong magnetic field to protect it. And so these two spacecraft, Blue and Gold, are going to be orbiting Mars, measuring the magnetic field, but also measuring the flow of these charged particles. Are they from the sun? Are they from Mars's atmosphere? Are they carbon dioxide? Are they oxygen? We don't know. We want to kind of learn about this.
Okay, so a lot of the previous vehicles that we've sent to Mars have been fairly focused on the surface.
Yes.
Like, we want to know what's on the surface, and then we want to know what's beneath the surface. But now we're sort of looking a little bit more into Mars's sky.
Yes, that's right. So there was one spacecraft called Maven, which was sort of a precursor for this, and it found evidence of this sort of particle stripping.
Maven was a satellite, right?
Yes, that's right. It orbited Mars. It was a satellite that orbited for a few... It's still there, actually. But yes, these are the next sort of generation. Better equipment, better detectors, and there's two of them. And what they will do is they will, firstly, for 6 months, they will follow each other in the same orbit and measure the magnetic field simultaneously to get sort of, double up on your data.
Yep.
And then after 6 months, they will switch orbits, and so they'll measure the magnetic field in different places at the same time to see.
How will they switch orbits?
They do have little engines on board, so that 500 kilos that we spoke about.
Some of it's fuel.
Some of it's fuel, and that's going to push them on different orbits.
Cool.
And that's so that they can measure the field in different places at the same time. So if there's a big solar flare, they can see how it affects the planet at different places at the same time.
I'll be interested to see how that switch goes.
Yes.
Like how that changing orbit goes.
Yeah.
It's just incredible to me that we're talking about a place that takes months to travel to.
Yes.
And we're going to tell our little space robots to move.
Yeah.
It's like, okay, you've done a good job now.
Now you can move.
Can you move to a different place?
Yeah, so it'll be an 11-month flight to get there, which is not the quickest you can get there.
Yeah.
But it is...
This is what you were talking about earlier with celestial mechanics.
Yes.
Oh, it's like manifestations. No, that's wrong. Celestial mechanics.
Yes, Mars is in the right spot as of the end of September until about the start of November to send spaceships to.
Okay.
So, it's one of the things we forget about when we talk about, we'll send humans to Mars one day. The best time to send humans to Mars only comes around every couple of years when Earth and Mars are kind of on the same side of the sun and you can send something there. If they're on the opposite side of the sun, I mean, you can get there, but it's very wasteful on fuel. It's very expensive.
Yeah.
It's not very safe. You need to kind of go past the sun.
Yeah.
So, you can only launch to Mars every couple of years.
I think at that point, surely the best thing is to, go out to Mars's orbit and wait there for Mars to catch up with you. But then you've got the issue of running into a planet as well.
And the interesting thing about this particular launch is it's the first launch of the New Glenn rocket.
Aha.
Now, I know most people don't care about rockets, but I do.
I like rockets.
I
think rockets are cool.
Yeah, we're in a renaissance of commercial rocketry at the moment.
Yes.
And obviously SpaceX is the big winner at the moment, but there are many, many companies coming to space that are developing rockets. Spaceflight used to be a government thing. Nations would launch rockets.
Yeah.
We still have the European Space Agency, but commercial rocketry is taking off, and Blue Origin is becoming a player in that.
Yes.
Blue Origin's a company owned by everyone's favourite billionaire.
It's Jeff Bezos.
Jeff Bezos, yeah. I know. Nobody
We've had
likes-
our rant about space tourism.
Yeah.
Not doing that again.
No, yeah, that's right. We did speak about Blue Origin recently. They launched the rocket that looks like a dick.
Yeah.
Just they launched the rocket that looks like an aubergine.
Phallic rockets.
Yeah.
Why? Stop.
Yeah, this one's particularly fun. However, that's the little tiny brother of New Glenn. That's called New Shepard, that little Willy rocket. It's called New Shepard. It's only, quote, only 4 stories tall. New Glenn is 100 metres tall, which, I don't know, what's that, about 25 stories tall?
But it would only take Usain Bolt like 9 seconds to run that.
Yeah, that's right.
It's just, if you think 100 metres up, so big. 100 metres long?
Yeah.
Not that big.
No, that's right. But yeah, we're all familiar with 100 metres now because of the Olympics.
Yeah.
And yeah, imagine a vehicle that big.
But yeah, if you then turned that track on its end, that's a big rocket.
It's a big rocket, yes. It's one of the biggest. Not quite as big as the Saturn V that sent people to the moon, but almost as big. The Saturn V was about 110 metres tall, I believe.
All I know that it is an expensive Lego model.
Yes, that's right.
Yeah.
Big, expensive Lego model. But the New Glenn is sort of designed in the same way as the SpaceX Falcon 9. It's designed to launch and then separate, and the second stage goes to space and it sends the satellite to space. But then the first half comes back to Earth and lands. And in fact, the patent for New Glenn was actually existing before the Falcon 9. So, believe it or not, Blue Origin had the idea first of landing a rocket on a barge in the middle of the ocean. And SpaceX beat them to it, and they do it all the time these days.
You know what? I'm just glad that we're thinking about reusable rocket ships.
Yes, that's right.
Yeah, and if everyone's doing good.
Yeah.
The more that, it's my environmental heart and my nerdy heart clash over rockets. But so the more reusable we can make rockets, the better.
Exactly. And so New Glenn is designed to be partially reusable.
What happened to Old Glenn?
Well, the rocket is named after John Glenn, who was the first American to orbit the Earth. So we all know Yuri Gagarin was the first human in space.
Yes.
And he actually orbited Earth on the first flight.
Yes.
But in the United States, they were a little bit behind, so they sent up Alan Shepard as the first American into space, but his rocket just went up and down.
Right.
And that's why they have...
So that's the New Shepard.
The New Shepard rocket just goes up and down. And then the New Glenn, named after John Glenn, it's designed to go into orbit, which is much harder than just going up and down. And so that's one of the reasons. It's taken them about 10 years to develop the New Glenn, and its first test flight, if all goes well, will be on the 26th of September. And it will be taking, of all things, the blue and gold Escapade spacecraft to Mars, which is a hell of a first flight, an interplanetary mission.
And also, if it goes wrong, they don't have that long to fix it because of that celestial mechanics.
Oh, the launch window. Oh, look, if it goes wrong, look, if it goes wrong, it's all off.
Yeah, but what I mean is, we're not waiting a couple months, we're waiting a couple years.
Sorry, I see what you mean.
Until...
Yes. Yeah, if the rocket doesn't launch, they can delay it by a day or a week.
Yeah.
But they can't delay it by 12 months, no.
Yeah.
They have to delay it by 2 years.
Yeah. Oh, that's...
It's pretty exciting. The funny thing is that New Glenn is a very heavy lift launch vehicle. It can put 45 tons into orbit.
Whoa! And we're only sending up
2 times 500 kilogram rockets. So it's spacecraft. Sorry. So it's comically overpowered for this mission.
Yeah. So I guess in that situation, you just don't put as much fuel in.
Yes, they will not fuel it fully. That's right. And the reason for this is that. The Escapade Blue and Gold spacecraft was supposed to launch on a different mission last year called Psyche to an asteroid. And that was supposed to be launched on a SpaceX rocket. But the Psyche spacecraft wasn't ready. And so they had to delay the launch of Psyche, by which time Mars was in the wrong position.
Oh.
So now it's come all the way back around, and Blue Origin said, we'll do that. It's a test flight. Yeah. Why not?
So if they get it wrong, it's actually doubling the delay. Pretty much.
Yeah, that's right.
Oh, my goodness. Oh, well, that's going to be sort of fingers crossed for space folk.
Yeah, and it'll be exciting because
Yeah.
SpaceX really needs a competitor.
Yes.
I mean, they're very good at what they do, but they really do need a competitor.
What is the phrase? Competition drives innovation or something?
Something like that.
Something
yeah.
like that.
Which does lead us perfectly into
Space fail of the
Fail
month. I just want to sing them. I want to sing all of them badly.
I love you singing. It's awful, but not as bad as mine.
Thank you. So I've written in my notes, boing! Astro's still up there, innit? Literally verbatim, that is what I've written down.
Boing, astronaut still up there in it.
Yeah.
Yep, that's the most UK sentence you could ever write.
Yeah. So this is partly because I can't spell Boeing.
Yes.
But also I think it's quite funny when they're yet again the focus of space fail, that we call them boing
Yeah.
instead.
Boing, yeah.
It is a bit of a boing moment.
It
So what
is.
are you doing, boing?
I didn't want to call this the space fail of the month a couple of months ago in
Yeah.
our previous episodes. I said
Yeah.
it was not as bad as it sounds, and
Well,
it's still not as bad as it
No,
sounds.
it was a
but
space success because we got the astronauts there safely
they're safe, yep.
despite rocket ship failures.
Yes, that's right.
However, Leon, have you ever gone on a work trip for a week and still been there several months later?
No, I would love to, because I've only been on 2 work trips, both of them to Japan.
Oh,
and
okay, that would
they
be
were
quite
only
a
for
nice
few
place
days.
to stay for several months by
I would
accident.
have loved to have accidentally stayed there for several months.
But these poor astronauts were promised a short visit to space and they've now been up on the International Space Station for months.
That's right. It was an 8-day test flight.
8 days. They
the-
were meant to be there for a week.
Yes, of the Boeing Starliner. This is what we're talking about, the Boeing Starliner. You've probably seen it in the news.
Yeah.
So it was an 8-day test flight of this spacecraft, which has had a troubled history.
Yes.
It had 2 uncrewed test flights where the first test flight had a lot of electrical troubles. The clock was off and it couldn't even dock with the space station. The second test flight was a success. It robotically docked with the International Space Station. And this is the third one with 2 people on board, Butch and Suni, as they're called. And they have gone to the International Space Station. They got there safely. Everything's fine.
good.
They're not in any danger. However, there's been a number of problems with the engines on the Starliner.
Yeah.
And you can't return home without engines that work. And so
Is the Starliner still there in space attached to the International Space Station?
as of this recording, it is, yes.
Right.
So a couple of days ago, it was announced that NASA was not going to bring them back. This is the big question. Were Butch and Suni going to come back on the Starliner and re-enter? Because the Starliner can re-enter. It's done
Right.
that safely twice.
Okay.
But the question is, would NASA bring them back on the Starliner, or would they wait until February when SpaceX brings one of their capsules back to Earth?
Right.
Would they come back on that? And NASA just decided that yes, we don't want to trust the Boeing Starliner. We're
Yeah.
going to bring them back on the SpaceX Dragon,
On the safe, proven
one that
rocket.
has been proven safe.
Yes. Because, I guess then, because this would have been the first time the Starliner comes back with people in it.
With people in it. Yes,
so,
that's right.
Yeah, and since it went a bit wrong on the way up, we definitely don't want those people
On the way back
on
down.
the way back down to
Yeah.
discover any more errors. Yeah.
Exactly. And it is, and again, I hate playing devil's advocate for Boeing because they really do deserve the criticism that they're getting.
They got a broken rocket ship.
Yeah, they got a broken rocket ship. The aeroplane manufacturing industry is in a bit of turmoil at the moment. But yeah, the best answer is it shouldn't have happened.
No.
The second best answer is the engines are on part of the spacecraft that is not actually going to stay attached to the capsule that brings the people home. So it's a 2-part capsule. The bit
Okay.
where the people sit
Yeah.
and the bit where the engines are.
Right.
And the problem is for Boeing that when they come back to Earth, the bit where the engines are detaches and it burns up in the atmosphere.
So
So,
they
never
can't
get
do
to inspect it.
diagnostics.
That's right. So
Right.
they have the only thing they can do is test it while it's there, and that's why
Right.
it's been so long. So it's too many news stories are quick to say this is the worst thing that's ever happened, and Boeing are completely stupid. And how couldn't they have brought it back already?
No,
And-
also, I agree with you. We definitely should not be encouraging companies to risk human life in order to get a more positive news story. Like, this headline should be, Boeing keeps its astronauts safe by not risking them on an
That's what it is.
unstable home mission.
Yeah.
Like, that is definitely, props to Boeing for taking the flak that they deserve, but, for
That's right.
taking the flak and still not going like, fine, we'll bring them back on the Starliner then.
Yeah.
Like, I'm very glad that, they've said this is a safety issue, and yes, it's their fault it's a safety issue, but the way that we solve a safety issue is not by putting human lives at risk.
No, that's right. And NASA is obviously on board with that. NASA is the masters of risk management ever since Challenger.
Yeah.
And for that reason. So so they'll come back.
This is a story which is genuinely written in blood. Like we are not. We're not doing stuff like that for very good reason.
No. So the plan is the SpaceX will launch Crew 9 end of September, roundabouts. Is their 9th crew flight. And instead of having 4 astronauts on board, it will have 2.
Right.
And then it will stay up there for 6 months. And then those 2 astronauts, along with Butch and Suni, will come back in February when Crew 9 capsule comes back to Earth.
Right.
And Boeing will pay for the entire thing of Butch and Suni.
Yes. Yeah. Do they also have to make up for the fact then that there are 2 other astronauts that aren't going up into space? Because I would be one, devastated if I was Butch and Suni and was meant to just have a quick trip to space, and then several months later I'm still there.
I don't think it's been announced which 2 astronauts are getting cut from.
Yeah, exactly. Like, you're going to space and then boing, it's gone boing, and now you don't get to go.
Yeah. Oh, look, I suspect they'll go up, 12 months from now.
Yeah.
They'd be right to be devastated.
Yeah, because it's a lot of prep to go to space. Like, astronauts aren't just like, I'm just going to pop to space now. You do a lot of training and
years in advance.
Yeah, and it's still such a limited thing that it's such an honour, which is one of the reasons that space tourism is getting a bit of flack from people who have trained to be astronauts. But anyway, not today. But yeah, like, I would be pretty devastated if I'd been promised this mission and then, like, obviously more important that we get the 2 people who have been stuck in space home safely, and also they're not just on holiday.
No,
on the ISS.
Going to space is not a holiday.
No, but they are, like, Butch and Suni are qualified astronauts, so they will be up there assisting with the research efforts that take place on the ISS.
100%, yeah, they are busy. And Butch and Suni have both led crews before, so this is not like their first time. They're not space tourists. They are 100% NASA astronauts.
Yeah,
NASA has paid for them to go there.
Yeah,
and so they're definitely, they know what they're doing.
Yeah, they're not just floating around on holiday.
No, but those the 2 poor buggers who are missing out on the Crew 9.
Yeah.
But I suspect they'll go up on maybe Crew 10.
How does stuff like that and like this work with supplies?
Yeah, good question.
Because they would have sent supplies up for 8 days.
Yeah, the funny thing is that the International Space Station needed a replacement. I believe it was a refrigerator.
Oh.
On the Boeing, as in, like, it needed it urgently, so they put one on the Boeing Starliner.
Right.
It went up, but to make room for that, they took out Butch and Suni's personal items.
No!
Because it's only 8 days, you'll be fine.
Yeah. Oh,
so they got the refrigerator up there. I think it's a refrigerator, I'm not quite sure, I can't remember. But,
A
however...
big piece of kit.
The big piece of kit. So, yeah, however, there was in addition to regular crew changeovers on the space station, there are also regular uncrewed service missions.
Okay.
And a few weeks, about a month ago now, a few weeks after Butch and Suni had launched, there was a resupply mission on a Cygnus spacecraft.
Right.
That carried their personal items and new supplies and things like that.
Probably enough food.
Yeah, food, extra.
Stuff like that.
There's plenty of supplies on the space station, a bit like your backpacker or your lunchbox. You've got your lunch that you need, but you can't have a little bit extra just in case.
Yeah.
You got to work late, and that's kind of what the space station has. It's got extra supplies. But, yeah, they now do have their own personal items on board, and there is the Crew 9 SpaceX capsule going up in a few weeks.
Yep.
And that will probably have some more stuff for them as well.
Oh, can you imagine, though, going to space for 8 days and then suddenly you're home after Christmas?
Yeah, that's right. Yeah, bye, Mum.
Bye.
See you in a week. I do want to finish with one more story.
Yeah.
Sorry, Morgan. This is going to be a nightmare for you to edit.
Sorry, we've gone long.
But the Cygnus spacecraft that went up, it launched on a SpaceX Falcon 9, but it was not designed to do that. It was designed to launch on an Antares rocket, which was a separate rocket, sort of half.
Who's Antares?
So Northrop Grumman plus a bunch of other people.
Right.
And it's kind of weird because the engines on the Antares rocket were built by Russia. The rocket itself was built by Ukraine. And then all the guidance and navigation was built by the European Space Agency.
Okay.
And then the headquarters and everything is administered in the United States. And so it launches from the United States.
That is a
then-
multicultural rocket.
Yeah, that's right. And then the Cygnus sits on top of the rocket. But of course, once Russia invaded Ukraine,
Yep.
and also the US government has cracked down on there's no more Russian engines in the United States. That's what they've said. They've got 5 years to
that's
phase out.
One of their sanctions, isn't it?
Yeah, that's right.
Yeah.
And so they've had to redesign, and so they're still redesigning the Antares to use other things. So
Right.
for now, they put the Cygnus on the SpaceX Falcon.
Okay.
And so I just want to finish with a beautiful quote from our Lord and Saviour of science communication and astronomy, Scott Manley.
Hey.
When he's talking about the Antares rocket, he says, "If only rocket science were as easy as international politics."
Oh, if only.
If only.
It's okay, Boeing. You'll get there one day.
Well, that's it for this episode of Please Look Up. It's been a hell of a time and a half, I would say. Thank you for being here, Beth.
Thank you for having me, Leon.
And thank you, everybody, for listening. This has been a great episode. We'll see you next month when we talk about the space news and the sky tonight for October. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.